Find the acceleration of a particle at time 2 seconds, given that its velocity is t sine 3t meters per second. We're given velocity, we need to find acceleration. It depends on t. T is the variable here, so there's going to be calculus involved. So quick recap, if you have displacement and you differentiate it, you get the rate of change of displacement with respect to time, also known as velocity. So working backwards, integrate velocity to get displacement. If you differentiate velocity, you get the rate of change of velocity with respect to time, or over time, which by definition is acceleration. And working backwards, integrate acceleration to get velocity. T sine 3t is our velocity. We want the acceleration, so we're going to need to differentiate. And this is the product of two functions, t and sine 3t. Therefore, we're going to need the product rule. Now, usually when I'm doing the product rule, I call one of the functions u and the other one v. I'm going to use different notation here because I don't want to cause any confusion or potential confusion with the v for velocity. So I'm going to call one of them f and the other one g. I've gone for letting t be f and let sine 3t be g. Then when you differentiate f, you get 1. F dot is the notation for differentiation with respect to time. So this f dot just means df by dt. The dot is a special notation you can use when you are differentiating with respect to time. Similarly here, g dot is what we get when we do dg by dt. Important 3 here, the derivative of sine 3t is not just cos 3t, it's 3 cos 3t. If you got that wrong, then you might want to revise the chain rule. That's what we were given. Velocity is t sine 3t. So our acceleration using the product rule, well, it's going to be f multiplied by g dot plus g multiplied by f dot. So we get 3t cos 3t. I'm doing f multiplied by g dot and then plus sine 3t from g multiplied by f dot.